Okay, so using the formula n factorial over r factorial time n minus factorial to find the value of 8, 4. Now, these are not the type of questions that are being asked in the exam, but you should know how to calculate using the formula. So if this is just a skill check question or a practice question, 8c4, 8, 4 over here means 8c4. That is equal to 8 factorial divided by 4 factorial times 8 minus 4 factorial. 8 factorial divided by 4 factorial times 4 factorial. 8 factorial can be expressed as 8 times 7 times 5 times 6, 6 times 5 times 4 factorial divided by 4 factorial times 4 factorial. 4 factorial and 4 factorial cancels out. Okay. So 8 into 7 into 6 into 5 divided by 4 into 3 into 2 into 1. You can simplify this out and calculate the value of 8. So if you calculate using the calculator, you are going to get 70. Okay, so you can check from the calculator as well that 8c4 is going to be 70. Similarly, 9c3 is 9 factorial over 3 factorial times 9 minus 3 factorial. 9 factorial over 3 factorial times 6 factorial. So 9 factorial can be expressed as 9 times 8 times 7 times 6 times 6 factorial divided by 3 factorial times 6 factorial. 6 factorial, 6 factorial are cancelled out. So 9 times 8 times 7 is 504 divided by 3 factorial. 3 factorial is 6. So the answer comes out to be 84. Okay, that's just a skill check question. Now, this is the question we need to discuss. Now, find the term independent of x in the expansion of x plus 5 upon x squared to the power of 9. The first thing that you are going to identify over here is that inside the bracket, there is no longer a linear term. So you can't say that the first term is going to be x to the power of 0 and the second term is going to be will have x to the power of 1. The third term is going to be x to the power of 2. No, you can't say that. Okay, so if you are asked to find the term independent of x, what is the meaning of the term independent of x?
So I'm not sure. Is it x to the power of 0?
X to the power of 0. Okay. And do you recall the formula that we did for a particular term in the last class? The particular term,
it was r plus 1.
r plus 1, that was equals to ncr a to the power of n minus r d to the power of r. The first term to the power of n minus r and the second term to the power of r, right? So I'll apply the same formula over here. So n value is 9. 9cr. I don't know what is going to be the value of r for which I'm going to get the term x to the power of 0. So that is what I need to find out. 9cr, first term is x. That's going to be 9 to the power of 9 minus r. Second term is 5 upon x squared. That is going to be to the power of r. So 9cr into x to the power of 9 minus r times 5 upon x squared to the power of r. Now, when you have applied the specific term formula, you're going to separate the coefficient and the variable. Okay. So 9cr becomes part of the coefficient. X to the power of 9 minus r, that's the part of the variable. 5 to the power of r, that's the part of the coefficient. X to the power of 2r. You're going to collect the coefficient on one side. So that's 9cr times 5 to the power of r. And you can simplify down the powers of x. So what is, using the rules of indices, what is x to the power of 9 minus r divided by x to the power of 2r? What will happen to the powers of x?
We subtract.
We subtract. So that's going to be x to the power of 9 minus r minus 2r. So 9cr times 5 to the power of r times x to the power of 9 minus 3r. Okay. So
the only thing I didn't understand is how did you divide x to the power of 9 minus r by x to the power of 2r? Won't you do like 5? Won't you like cancel the powers from 5 minus r? No, they're not the same base. Sorry.
No, the base needs to be same. So over here, the base is same. X to the power of 9 minus r.
Yeah.
and x to the power of 2r.
Since we haven't done any operations, how can you divide it directly from x to the power 9 minus r?
Like you are asking, how did I solve this?
Yeah, like how did you end up with x to the power of 9 minus r divided by x to the power of r?
Okay. So when I applied this formula 9CR a to the power of n minus r b to the power of r, 9CR n value over here is 9. Okay. So 9CR is the first term. Like this is the first part. Now a is the first term over here, that is x. So x to the power of n minus r, that is 9 minus r. Okay. Times the second term, that is 5 upon x square to the power of r. Right? Is this step clear?
Yes, so the step is clear.
Now 9CR will be a part of the coefficient, and over here 5 to the power of r will be part of the coefficient. And this is the variable
Right.
x to the power of 9 minus r divided by x to the power of 9 minus r divided by x to the power of 2r. Now using the rules of indices, when the bases are same and are being divided, the powers are going to be subtracted. So x will have a combined power of 9 minus r minus 2r. Does that make sense?
So again, I didn't understand. If you're going to multiply all three of these, how does it end up as divide? Yeah. How do you end up with x to r?
So what is a multiplied by c upon b? Although I'm multiplying a by c upon b, but can't I divide a upon b and then multiply by c? That's also the same thing.
Okay. Okay, good.
Okay, fine.
Yes, sir.
Okay, sure. Now see the next step. Are you clear with these steps?
Yes, sir. I'm clear with these steps.
Okay. So that's the general term in the expansion. So if I would have known the value of r, I would have gotten the specific terms. But right now I don't know the value of r. How will I get the value of r? See, I need to find the term independent of x, which means that x must have the power of 0. So over here, x power must be equated to x to the power of 0. So I want the term with x to the power of 0. So I'll equate x to the power of 9 minus 3r with x to the power of 0 for the independent term. Independent term, that means
you cross out the base,
term.
then you go 9 minus r equals 0.
9 minus 3r equals to 0. You are going to equate the powers. So 3r is going to be 9 and r is going to be 3. So it is the fourth term basically. R3 means the fourth term in the expansion. So to find the coefficient or this value, the coefficient of x to the power of 0, you're just going to find 9c3 into 5 to the power of 3. What is 9c3 into 5 to the power of 3?
Yeah.
It's 10,500, right?
Yes, sir.
Okay. And if you would have plugged 3 over here, what would you have got?
Where 9 minus you get 3, x to the power of 3.
No, when r is 3.
Sorry, when I'm saying 0, x to the power of 0.
Right? So can I say that this value is the coefficient of x to the power of 0?
Yes, sir.
Which is the term independent of x. For x to the power of 0, we don't write x to the power of 0, that is 1, right? So in the expansion, we are going to be getting this term 10,500 as a constant or a term independent of x.
Yes, I got it.
All right. I'll just pause the recording. I want you to write down this question and solve it on your own once. So the first three terms in ascending powers of x in the expansion of 1 minus x to the power of 6 are going to be calculated as follows. 6c0, 1 to the power of 6 minus 0, second term to the power of 0. 6c1, 1 to the power of 6 minus 1, x to the minus x to the power of 1, plus 6c2, first term to the power of 6 minus 2, second term to the power of 2. Okay, these are the first three terms. So if you calculate this, you're going to get 1 minus 6x. 6c2 is 15, so 15x squared. Are we all getting the same answer for the first part?
Yes, sir.
Yes, sir.
Okay. Zores, where did you go wrong?
For me, I used this kind of formula. Basically, it's six. I think this exclamation mark is called radical, right?
The factorial.
Yeah. So 6 factorial divided by 0 factorial bracket 6 minus 0. So basically, we use like n minus 1, then n minus 2, n minus 3 in order.
Okay. Yeah, but why aren't you
It's
using
a
P?
binomial theorem.
It's a binomial series. What you are telling is binomial series. That's
Yeah.
also a correct formula, but eventually you should be getting the right answer, the same answer as mine. Okay, but the formula that you are using will be used in P3, not P1. In P1, the examiner expects you to know this. Okay, just use combination to find the values. So even if, like, firstly, you are not expected to use that formula in P1, okay, because that's taught in the later stage in P3. Secondly, it's far more easy to use this expansion formula using the combinatorics. Okay,
Okay, sir.
so try using this in the second part, 1 plus 2x to the power of 6. So the first term is going to be 6c0, 1 to the power of 6 minus 0, second term to the power of 0, plus 6c1, 1 to the power of 5, second term to the power of 1, plus 6c2, 1 to the power of 4, second term to the power of 2, and so on. So 6c0 is going, you can use your calculator at any stage, okay? 6c0 is 1, 1 to the power of 6 is 1, 2x to the power of 0 is 1. So the first term is 1. Then 6c1 is 6 times 2, that's going to give you 12x. Then 6c2 is 15. 15 times 2 square is, 15 times 2 square, 15 times 4 is 60, x square. These are the first three terms in the expansion of 1 plus 2x to the power of 6. Is everyone with me till these two steps?
Yes, sir, I got both right.
Okay. Now the second part says, hence, whenever such this command word is used, you have to use the answer from the previous parts. Hence, find the coefficient of x squared in the expansion of 1 minus x times 1 plus 2x to the power of 6. Now, 1 minus x times 1 plus 2x has a combined power of 6, okay? That means the power 6 is on 1 minus x as well and 1 plus 2x as well. Okay, now isn't these the same expressions that you have expanded in the first part till the first three terms? Right, they are the same expressions. So the expansion of 1 minus x to the power of 6 up till the first three term was 1 minus 6x plus 15x squared. And the expansion of 1 plus 2x to the power of 6 for the first till the first three terms was 1 plus 12x plus 60x squared. Right?
So why do you write the ellipsis after 60x squared? And oh wait, no, it keeps continuing. Never mind.
Okay. Now you are only interested in getting the interested in getting the coefficient of x square in the multiplication. So I will not bother to multiply each and every term together. I'll just multiply the terms selectively so that I get the coefficient of x squared. So over here, one should be multiplied with which term to get the coefficient of x squared?
So you can multiply 1 with 60x squared and then 1 with
60x
15x squared and then minus 6 times 12.
Minus 6x should be multiplied by the term in x, with that is 12x. And 15x squared should be multiplied by 1, so that you only get the term in x squared. So to find the coefficient of x squared, I'm going to multiply 1 with 60x squared. I'm going to multiply minus 6x with 12x, and I'm going to multiply 15x squared with 1. Okay, so 60x squared minus 72x squared plus 15x squared. You add these terms, 60 minus 72 plus 15, you get 3. So after multiplying, the coefficient of x squared comes out to be 3. So that's your answer. Zora, is clear?
Yes,
So could you repeat from the start?
Yes, sir.
Okay. All right. Abdul Rahim, I'll just go over it.
So I'm
Sorry, Abdul
Rahman.
Rahman. Yeah, I'll just go over what we have done in this question. The first part was expand 1 minus x to the power of 6 till the first 3 terms. So using the binomial expansion formula that I taught you in the earlier class, you're just going to expand till the first 3 terms, and this is the expansion that you get. The first term is 1, the second term comes out to be minus 6x, and the third term comes out to be 15x squared. You're going to do the same thing for 1 plus 2x to the power of 6 as well. You're going to use the formula 6c0, 1 to the power of 6 minus 0, 2x to the power of 0 for the first term, 6c1, 1 to the power of 6 minus 1, 2x to the power of 1 for the second term, 6c2, 1 to the power of 6 minus 2, 2x to the power of 2 for the third term. So when you evaluate this, the first term comes out to be 1, the second term comes out to be 12x, and the third term comes out to be 68 squared. So these are, the question just asks us to expand till the first 3 terms. So we are just going to expand till the first 3 terms. These are the answers for part A and part B. Now in the second part, it says hence find the coefficient of x squared. Whenever they use the word hence, it's a command word, which means that you have to use the answer from the previous part. You need to find the coefficient of x squared in the expansion of 1 minus x. 1 minus x times 1 plus 2x combined power 6. Now this combined power 6 means that the power of 6 is on 1 minus x as well, and the power of 6 is on 1 plus 2x to the power 2x as well. So 1 minus x to the power of 6, the first 3 terms were 1 minus 6x plus 15x squared. The first 3 terms of 1 in the expansion of 1 plus 2x to the power of 6 were 1 plus 12x plus 60x squared. You are just interested in finding the coefficient of x squared. So the coefficient of x squared is going to be found out by multiplying 1 with only 60x squared, by multiplying minus 6x with only 12x, and by multiplying 15x squared by 1. So when you add these terms, you get 3x squared. So the coefficient of x squared is 3. That's the final answer.
Okay. Okay, understood, sir.
Okay, everyone, let's try the second question. I'll just pause the video, pause the recording, and then you can do the second question. So in this question, we are finding the terms in x squared and x cubed. Now, notice that inside the bracket, you have a linear expression. Whenever you have a linear expression inside the bracket, the first term is going to be the term with x to the power of 0. The second term is going to be the term with x to the power of 1. The third term is going to be the term with x to the power of 2. The fourth term is going to be the term with x to the power of 3. So for this simple question, you can just expand till the first 4 terms, or you can directly take out the x square is going to be the third term and x cube is going to be the fourth term. Okay, so the third term in this sequence is going to be 6c2. Okay, because our expansion start from 6c0, then 61, then 62. So the third term is going to be 62, 1 to the power of 6 minus 2, minus 3x upon 2 to the power of 2. Okay, and the fourth term is going to be the term with 63, 1 to the power of 6 minus 3, minus 3x upon 2 to the power of 3. Let's use the calculator and evaluate this. 62 is...
Can you tell me again?
Just a second. Multiply by 9 upon 4. So I'm getting 135 x square upon 4. And for the fourth term, 63. So you are going to use your calculator to evaluate this. 63 multiply by, so minus 3 upon 2, the whole thing cube. And you multiply it with 63, you get minus 135 upon 2x cube. Okay, now I'll explain again. Okay.
I got this answer, but isn't this different from this answer?
Yeah, it's different. Oh, no, it's the simplification. This one is a simplified answer than this one. Okay, when you simplify,
I got this one right, I just messed this one up.
Okay. Abdul Rahman, I'm just going to repeat for you. So you were asked to find the term in x square, okay, and the term in x cube. So the term in x square is going to be the third term, that is 62 into a to the power of 6 minus 2, b to the power of 2. So if you calculate this, use your calculator to calculate 62 multiply by minus 3 upon 2 is 9 upon 4. So multiply this result. Okay, you're going to get 135 upon 4x square. And when you solve this for the fourth term, that is going to be the term in x cube, 63, 1 to the power of 6 minus 3, second term to the power of 3. When you solve this, you're going to get minus 135 upon 2 x cube. Zores, is this thing clear to you?
Sir, why, like
Yes,
you said,
sir.
1 to the power of 4, why didn't you multiply 6c2 with 4, then multiply it with negative 3 over 2?
The formula in the expansion was, okay, the first term in the expansion is nc0. Whenever you have a plus b to the power of n and you are asked to expand this, the first term is nc0, a to the power of n minus 0, that is n, second term to the power of 0. Then the next term is going to be nc1, a to the power of n minus 1, second term to the power of 1. Then the third term is going to be nc2, a to the power of n minus 2, b to the power of 2. Then nc3, a to the power of n minus 3, b3, and so on. The list goes on. Now, over here, you want the term in x square and x cube. So you are going to use these are the two terms. Okay. So this one is 62, n value is 6. 62. The first term is 1 over here. The second term is minus 3x upon 2. Okay, Abdul Rahman. So 62. The first term is 1. So 1 to the power of 6 minus 2, that is 4. The second term is minus 3x upon 2. That is going to be to the power of 2. The same power. Okay. So when you solve this, you get 135x squared upon 4. Are you clear with this, Abdul Rahman?
Okay, sir. Okay.
Then the next term is going to be nc3. So 6c3, 1 to the power of 6 minus 3. Second term to the power of 6, second term to the power of 3. So you get minus 135 upon 2x cube. Okay, now for the second part, given that there is no term in x cube, Hassan, what does this mean? There is no term in x cube.
No.
The only way there could be no term in x cube is when the coefficient of x cube is 0. Okay. The only way that there could not be any term in x cube in the expansion is when the coefficient of x cube is 0. Now the question says that there is no term in the x cube in the expansion of k plus 2x times 1 minus 3x upon 2 to the power of 6. What does this mean? That this means that k plus 2x when multiplied by the expansion of 1 minus 3x upon 1 minus 3 upon 2 times x to the power of 6, in this expansion, there is no term in x cube, or the coefficient of x cube is 0. So if you look at this part, this is similar to the expression given in the first part, whose second and the third term are you already know. So k plus 2x is being multiplied by you don't know the previous terms, right? You only know the term in x square, that is 135 upon 4x square, and a term in x cube 135 minus 135 upon 2x cube, and you don't know the rest of the terms. What should k be multiplied with to get the term get the term in x cube?
You minus 135 over 2.
Minus 135 upon 2x cube. Okay, and what should 2x be multiplied to get the term in x cube? 135 upon 4x square, right? So you're going to multiply k with minus 135 upon 2x cube, and you're going to multiply plus 2x with 135 upon 4x square. K times minus 135 upon 2, that's going to be minus 135k upon 2x cube, and 2x times 135 is going to be 135 upon 2x cube. Okay, now if you take x cube common, you're going to get minus 135 upon 2k plus 135 upon 2. Is that correct? This is the coefficient of x cube. So what should be the coefficient of x cube as far as the question is, as far as this question is concerned? If you don't want the term in x cube, what must be the coefficient of x cube?
It must be the same.
It must be the same as what? What should be the value of this?
Wait, should be 1.
No, we don't want the term in x cube. The question says there must be no term in x cube. So what should this term be equal to?
Sorry, equal to 0.
It should be equal to 0. Good. So you're going to set this term equal to 0. Minus 135 upon 2k plus 135 upon 2 should be equal to 0. So therefore, if you solve this equation, so what must be the value of k?
1.
1. Okay. Just go over the working for the second part and let me know if there are any other questions.